On May 2, 2025, infrared footage captured an extraordinary scene unfolding over the Black Sea. A Russian Su-30 fighter jet streaked across the night sky, when suddenly, from the waters below, a bright flash erupted. A missile climbed rapidly upward, tracking the aircraft. Moments later, the $37 million fighter was engulfed in flames, plummeting toward the waves. Within minutes, the second Su-30 suffered the same fate. The strikes didn't come from another aircraft or conventional air defense system. The missiles launched from a weapon that wasn't supposed to exist, a remote-controlled Magura V7, costing just $273,000, no larger than a speedboat, mounting American Sidewinder missiles originally designed for fighter jets decades earlier. Advanced fighter jets now faced a threat from the most unlikely source: unmanned surface vessels operating in complete darkness across hundreds of miles of open water. The Morura drone boat. Ukraine's maritime drone program was born out of necessity. Facing Russia's overwhelming naval superiority in the Black Sea, Ukrainian forces began developing unmanned surface vessels in 2022, not as experimental technology, but as an urgent countermeasure to protect their coastline. The Magura V7, its name derived from Maritime Autonomous Guard Unmanned Robotic Apparatus, first gained international attention in November 2023, when it destroyed Russian landing craft at a naval base in Crimea. Unlike other naval drones, these vessels were designed specifically for combat operations rather than reconnaissance. Each craft measured just 18 feet in length, weighed under 2,200 pounds, and could travel up to 500 miles on a single mission, all while carrying 440 pounds of explosives. Initially, these drones operated as maritime kamikazes, sacrificing themselves in direct impacts against Russian warships. The approach proved devastatingly effective. In February 2024, Magura drones struck and sank the missile corvette Ivanovets, followed by the landing ship Zazar Kunikov 2 weeks later. By March, they had claimed another victim, the patrol ship Sergei Kotov. Each success drove Russian naval vessels further from Ukrainian shores and deeper into protected harbors. But Ukraine's Defense Intelligence Directorate, the HUR, had greater ambitions. Working with private defense companies, they began developing the larger Magura V7. While previous maritime drones had been limited to attacking ships, the V7 would target an entirely different domain: air defense. The evolution represented a significant technical challenge. Transforming a maritime platform into an anti-aircraft system meant dealing with complex problems related to targeting, stabilization, and missile integration. The V7's hull was widened to accommodate launch rails for air-to-air missiles, while its electronics were upgraded to track aerial targets, a capability no previous naval drone had ever possessed. By December 2024, the system had progressed enough to attempt its first operational deployment. In a surprising demonstration, a modified Magura using an adapted Soviet R-73 missile successfully downed a Russian Mi-8 helicopter near Crimea. While this achievement hinted at the system's potential, the HUR continued refining its design, looking toward an even more ambitious target: Russia's frontline fighter jets. Enter the Sidewinder. To effectively take on this enemy, Ukraine turned to a weapon with an illustrious history. The AIM-9 Sidewinder first entered service with the United States Navy in 1956. Since then, this infrared-guided missile has undergone continuous evolution while maintaining its basic design principles. The weapon has achieved over 270 aerial victories across dozens of conflicts, making it the most successful air-to-air missile in Western military history. It was the AIM-9M variant that would eventually find its way to Ukraine's drone boats. At approximately 9.5 feet long and weighing 190 pounds, the missile can reach speeds exceeding Mach 2.5 and strike targets up to 22 miles away. Its infrared seeker can lock onto aircraft from any angle, a vast improvement over early models that could only target exhaust heat from behind. Nevertheless, adapting it for use with the Magura V7 would not be easy, as the missile had never been designed for naval deployment. Rather than the controlled environment of an aircraft weapons bay, it would now face the harsh realities of salt spray, wave motion, and variable humidity. To protect the missile's sensitive infrared seeker heads, engineers would need to develop weatherproof covers for them, while ensuring these could be reliably removed before launch. The missile's guidance system also required recalibration to account for the constant pitching and rolling of a small vessel on open water. The other issue, perhaps even more critical, was that the AIM-9M lacked high-off boresight capabilities found in newer missiles designed to engage targets at extreme angles. This meant the drone boat would need to physically point its launch rails in the general direction of the target aircraft, a significant challenge when aiming at fast-moving jets from an unstable platform. Despite these engineering hurdles, by January 2025, Ukraine had begun mounting the US-supplied Sidewinders on their marine drones. Flight tests conducted in remote areas of the Black Sea demonstrated the system's potential, but the true test would come only when facing an actual aerial target. The weapon, designed in the 1950s to be fired from fighter jets, was about to take on an entirely new mission that its creators could never have imagined. The May 2nd attack. As dawn approached on May 2nd, 2025, 3 Magura V7 drone boats, each equipped with a pair of AIM-9M Sidewinder missiles mounted on elevating launch rails, slipped out at their secret base on Ukraine's Black Sea coast. Their mission would target Russian aircraft operating near Novorossiysk, a major Russian port, approximately 31 miles from the engagement zone. The first engagement began when the drone boat's specialized infrared detection systems identified a Russian Su-30 SM fighter flying at low altitude over the water. These multi-role fighters had been conducting regular patrols to counter Ukrainian naval activities. With a combat radius of over 930 miles and advanced sensor systems, the Su-30 SM represented the elite of Russia's frontline air power in the region. Video footage released by Ukrainian intelligence shows the moment of attack from the drone boat's perspective. A targeting bracket appears around the heat signature of the Russian jet as it passes overhead. The missile launch rail elevates to position, and the protective cap over the Sidewinder's seeker head is jettisoned. Seconds later, the missile ignites, climbing rapidly toward its target. The Russian pilots had no warning. Unlike ground-based air defense systems that emit radar signals detectable by the Su-30's threat warning receivers, the passive infrared tracking used by the drone boats left no electronic signature. The first indication of danger came only when the missile's rocket motor ignited, by which time it was already too late. The infrared footage shows the moment of impact, a bright flash as the Sidewinder's proximity fuse detonates its 20-pound warhead near the aircraft. Fragments tear through the fighter's fuselage and engines, sending it into an unrecoverable dive toward the sea below. The two-man crew managed to eject successfully and were later rescued by a civilian cargo vessel in the area. Minutes later, a second Su-30 faced the same fate. According to Lieutenant General Kirilo Budanov, head of the HUR, only 2 of the 3 drone boats opened fire during the engagement, with the third apparently serving as a backup or communications relay. The crew of the second aircraft did not survive the encounter. Russian military bloggers acknowledged the losses but disputed details of the attack. The popular war correspondent Kitten Telegram channel complained, quote, "The enemy seized the initiative in the Black Sea. The enemy has an overwhelming advantage in the use of unmanned boats with the ability to attack in any part of the water area and keep the coast of the Russian Federation and the adjacent airspace under control." A more detailed analysis from Russian military expert Vladislav Shurigin revealed that the Su-30 was shot down, quote, "using the same tactics, lured it out and caught it." His assessment of the incident suggested that the Russian air patrols had been deliberately baited into an engagement zone where the drone boats waited, a strategy that proved devastatingly effective, claiming 2 advanced fighters in a single operation. The next day, the Ukrainian Ministry of Defense released a triumphant statement, emphasizing that this marked the first confirmed instance in warfare history of unmanned surface vessels successfully downing fixed-wing fighter aircraft. Strategic implications. The downing of 2 Su-30 fighters by Ukrainian drone boats represents more than just a tactical victory. It fundamentally reshapes the strategic calculus throughout the Black Sea theater. Where the Su-30 cost $37 million, the drone boat cost just $273,000. This 135-to-1 cost ratio exemplifies asymmetric warfare at its most effective. Russian aircraft that once operated with relative impunity over the western Black Sea must now contend with a threat invisible to radar and nearly impossible to detect visually at night. Fighter pilots, accustomed to watching for surface-to-air missiles from land, now face danger from the vast open waters below. Russian military planners responded quickly, ordering their aircraft to maintain higher altitudes and greater distances from areas where Ukrainian drone boats might operate. According to open-source intelligence reports, Su-30 and Su-35 flights near the Ukrainian coast dropped by approximately 70% in the weeks following the attack. The Russian fighter patrols pushed back. Ukrainian naval drones gained greater operational freedom to interdict Russian shipping, attack naval assets, and potentially threaten Crimean ports. The psychological impact on Russian naval crews is equally significant, knowing they've lost their protective air umbrella. The technological breakthrough has not gone unnoticed by other nations. Naval defense contractors from multiple NATO countries have reportedly reached out to Ukraine, seeking technical details about the adaptation. Converting air-to-air missiles for maritime launch potentially offers a low-cost method to proliferate air defense capabilities across smaller vessels that couldn't otherwise accommodate traditional systems. For Russia, countering this new threat presents significant challenges. Their primary response thus far has involved deploying FPV drones to hunt Ukrainian USVs, but these small quadcopters have limited range and endurance. More sophisticated solutions like shipborne close-in weapon systems or dedicated anti-drone vessels would require significant investment and time to implement. What comes next? While Ukrainian ingenuity deserves recognition, the true significance lies in what happens next. Military forces worldwide are undoubtedly studying this operation, seeking to both replicate its success and defend against similar threats. The global defense industry, constantly seeking asymmetric solutions to conventional problems, will likely accelerate development of similar capabilities. Countries unable to afford advanced fighter jets may find drone boats provide a cost-effective deterrent against aerial threats. Meanwhile, nations with sophisticated air forces must now consider how to protect their valuable assets from this previously unanticipated danger. Looking toward the future, the most intriguing question isn't whether this technology will spread. It undoubtedly will, but how quickly countermeasures will emerge. In this endless cycle of measure and countermeasure, Ukraine has introduced a powerful new variable. And as two Su-30 fighters rest at the bottom of the Black Sea, military planners worldwide face an uncomfortable truth. Sometimes the most disruptive innovations aren't the most complex or expensive. They're simply the ones nobody saw coming.